That was our first example. Let's think of a more curly one where you see why I need all three of them. Okay? Let's consider this guy. Okay? If we consider the same point, I'm not going to draw it. I wonder if you can picture it in your mind without me drawing it. Okay? If I consider x equals 0, then when I come from the left, 0, negative. Okay? As I come from the left, I'm having small negative values, but they're being squared, aren't they? Right? They're being squared. So therefore, I'm going to be, where am I going? Where am I going? I'm going up to infinity, right? These are microscopically small numbers. Really, really small numbers on the denominator, which means the whole thing is big. It's approaching positive infinity. Okay?
Does it matter how fast it's approaching?
In this case, no, it doesn't. So if I'm approaching, I'm going to be, and I'll show you this in a second, why it doesn't matter how fast you do it, as long as you do. Okay? When I come from the other side, from the right, okay, 1 over x squared, you're still getting astronomically small numbers on the denominator. It sounds a bit funny, isn't it? Astronomically small. Really, really small, right? So small numbers on the denominator means really, really big numbers in total. It's still going to infinity. Now,
Oh, wait, is it
Right?
negative infinity?
no, it's squared. It's squared, right? So here's what I've established so far, right? Here's what I've established so far. I have this part. Approaching from the left, approaching from the right, same value, of course. Once I get to this guy though, I'm in trouble. I'm in trouble. Because I'm defining by 0, right? So this guy is undefined. So what's going on? Okay, let's draw this guy. Let's draw this guy. He looks almost exactly the same as that. Almost. There we go. That's not bad, right? Which of course you could have told me before, because right here, see how that's a 2? That's a 2. It's an even power, which means what kind of symmetry are you expecting? Even symmetry, just like you have odd symmetry here. Make sense? Yes.
So for your first example, you said let f of x equal 1 over x before you started the question. Is that a sort of like setting out that you should do for every question?
Yeah. Okay, so that's a great question. If the question is supplied to you in a useful way, if you're trying to, can you see, to talk about any of this, you need to the function has to have some kind of name, right? If it was this, if it was y equals 1 over x, strictly speaking, you can say this, right? Because y is a function, and the variable you can stick into it is x, but it's a bit weird because, like, who knows whether that's y is a function of x or y is multiplied by x? Like, it's a bit ambiguous, really. So if it doesn't get given to you in this form, I put it in that form, just so that you can actually say this, and you can refer to this definition. Okay. So I've got some asymptotes here, right? I've got x equals 0, where I'm undefined. This, by the way, gets to the question that was being asked before. This guy approaches, what's that horizontal asymptote there? Horizontal asymptote is y equals 0, right? Now, 1 on x squared, is it going to approach that asymptote faster or slower than this guy? What would you think?
Same.
Okay, now this is. I'm just gonna give all the answers. Give all the answers. Throw everything and something will stick, right? Let's just think about this, right? We're going towards 0. Okay, pick a number. Pick a number.
50,
How-
16.
You guys pick hard numbers. How about 100? Okay, zeros are easy to work with. Okay, now at x equals 100, how close am I to my asymptote here? Answer: I'm at 1 over 100, right? Okay, at the same point, how close is this guy? Answer: 1 over 10,000. Which one is closer?
So that one's closer.
Yes.
Because it's going faster.
It's exactly right. So it grows faster. Now, but here's the point though. Coming back to your original question, it's still asymptotic to y equals 0. It is no more asymptotic. It's like, oh, I'm really, really asymptotic? Whereas this guy's just like a little bit asymptotic. Like, you can call yourself an asymptotic, right? They're both asymptotic, right? That's exactly right. So it doesn't matter whether one approaches faster or slower. I can still go arbitrarily close. I just have to go a bit further with this guy, don't I? 100 times further. But that's okay, I can do it.
I swear